So the last system we're going to look at here is the Ionic Greek system, which is said to have developed from the Aegean numerals sometime between the 3rd and 5th centuries BCE, where it's a bit of a matter of discussion exactly when they came to be. But for these, it is a decimal system, much like ours, where instead of having those nice place digit values that we do, they had unique numerals for every one of the values 1 through 9, then every single one 10, 20, 30, 40, 50, 60, 70, 80, 90 uniquely, and similar for the 100s up to 900 along the letters of the alphabet, with a couple of added special ones in there at the end, like Sampai for 900. Where one feature that the Ionic Greek numbers did not have was a specific value for 0. But it actually does have a whole lot in common with ours, and to me anyway, that does lead to a question of why exactly we ended up using Hindu-Arabic, or for that matter, Roman, instead of this system here, when it has so much in common. Well, maybe you wouldn't want to keep all of the letters, because it's a bit inefficient when you get that many different characters for similar things, but could have been modified. And for that matter, we do still use a lot of Greek in math. If you pay attention, a lot of notation is determined with those Greek letters. So it's interesting, at least to me, to wonder why it is that we ended up with one and not this. But in particular, when we're talking about these values, they do represent them in a way that's much like ours, except instead of saying something like 32, they would specify the value for 30 and then the value for 2, where the value for 30 in this case was lambda, and the value for 2 was beta. So if they want 32, they would use lambda beta. But let's get one more example, thinking about how we construct these numbers. So for this, we want to represent the value chi nu beta as a Hindu-Arabic numeral. So we can see that with chi, we have a 600, so well, I'm going to try and draw chi and probably embarrass myself. But that's not so bad, at least for me. Chi was never one I was very good at. But we have chi is 600, and then nu, it's a convenient one, looks a lot like a V, except there's a little bit of an extra thing in there. But nu is 50. And finally, we have beta again. Usually I'm good at beta, and that's not so bad. For beta, we have another 2. So you put all of this together, and you'll end up with the value for chi. Oh, that's a terrible chi. Nu beta. Maybe this is why we don't use Greek, because I can't write it. Will end up being 652. That's how you would make that conversion. If you want to go the other way, it would work in the same way. You'd identify the hundreds value, the tens value, and the digits value. But that's all we're going to get for chapter 4. Next, we're going to move into chapter 5, where we're going to start talking about a new topic called number theory. That's what we're getting next. I'll see you in there.